So hello folks, a very good morning to all the viewers who are watching my video at present. I hope you have enjoyed the session on the previous session or part 1 section of this Windows 11 uh, hardware to cloud security. So in this video we'll be discussing about hardware security. Okay, so in the part 1 video we have discussed about the introduction part of this content, and we'll be moving forward the hardware security. Okay, so let us begin the session regarding hardware security too. Okay. So this is how the hardware security is. So before going forward or delivering the lecture or giving a glimpse of information from a book, so before that I just want to make you signify, make want to clear that if you are new to this channel, please subscribe the channel, like the channel, share the channel as soon as possible for more updates on this. Okay, so for updates you need to subscribe the channel. Unless and until you will not subscribe, you will not get the latest update on this. So I will also make it clear that it usually belongs to science and technology from UPSC civil service examination. So that's the reason why I'm been posting these all videos regarding the securities and the operations which usually we are been governed by. Okay, so let me begin the session regarding the hardware security of this. So what actually hardware security is, how actually we are performing hardware security. So here we have a glimpse of this analysis that hardware security is the root to trust, we can say, or silicon assistant security also, the components which usually governs on. So today's ever involving threat protection or requires strong alignment between hardware and software. We all know that software technologies usually to keep user data and devices protected. The operating system alone cannot protect. Okay, so operating system alone cannot protect from the cyber threat or cyber criminals. Okay, so once they gain a foothold or induct or can be difficult to detect while engaging in multiple nefarious activities. Nefarious, nefarious, please keep it a note on this, because whoever been learning securities guidance or security, we can say in simple words, cyber security, who are been learning. So please keep in mind that nefarious activities are very rarely that ranges from stealing important data and credentials to implanting malware into low level device framework. Okay, firmware, once malware is installed in firmware, it usually becomes difficult to identify and remove. Okay, so these new threats call for computing hardware that is secure down to the very core, including hardware chips and processors which usually store the sensitive business information. Okay, so with hardware based protection we can enable strong mitigation, okay, against entire classes of vulnerability, okay, that are difficult to thwart with software alone. Hardware based protection can also increase the system's overall security without measurable slowing the performance or compared to implementing the same capabilities in software too. Okay, so while coming to Windows 11 security or Microsoft Security Council or Microsoft Security provision of hardware devices, so Microsoft has raised the hardware security bar to design the most secure version of Windows ever, from chips to cloud. Okay, we carefully chosen the hardware requirement for default security features based on threat intelligence or TI, threat intelligence global regulatory requirement, and our own MST, okay, Microsoft security team, who have worked with our chips and devices manufacturing partners to integrate advanced security capabilities across software frames and hardware. Okay, so this is how actually the introduction of the hardware chips providing a very secure environment to hardware to software. Okay, not because we even know that, or not even a single person can do all the tasks. It is all about a team. We need to work on a team. In the similar fashion, unless and until we cannot give a protection only to its software rather than giving protection to its base foundation itself, that is all about hardware skills or hardware implementation. So unless and until we do not protect the hardware, then it is very difficult to make a evidence, to make a we can say that to make a protective security okay, to its software. Okay, so that's what here it is been written, chips to cloud. Okay, so hardware root of trust. What actually hardware root of trust usually meant by? So the hardware root of trust usually used to or helps to protect, or we can say protect and maintain the integrity of the system. Okay, as it is already written, protects and maintain the integrity of the system. Okay, so in the form of load frames, in the form of launching the operating system. Okay, so the root of trust, which usually meets the multiple important security goals. Okay, the root of trust is usually meant to require the multiple trust among the hardwares, or among the installation of the chips. Okay, for an example, let me take an example. Here it is also written example. Secure boot processes provides a secure startup environment. Okay, that only allows devices to boot with software trusted by the OEMs. Okay, when the PC stands, the framework checks the signature of each piece of boot, including software, including UEFI framework driven, also known as option room, EFI applications, and many more. Okay, so these are the best example of how actually the root of trust usually meant by. And in addition, hardware root of trust provide highly secure area, isolating the operating system and application for what, for cryptographic keys or data codes. Okay, this protection helps in mitigate attack against the Windows authentication stacks, single sign or token, and the Windows Hello biotic stacks and BitLocker volume encryption keys. Okay, this is how the chips usually protects on root to trust of Windows hardware. Okay, so then after we'll be discussing about trusted platform model. So what actually this trusted platform model is about? So TPM. Okay, so that is all about trusted platform module. Technology is designed to provide hardware based security, okay, related to function. TIP provides security privacy benefits for system hardware, platform owner, user. BitLocker, Defender, Systems Guard, and other features rely on TPM capabilities such as key generation, secure storage, encryption, boot integrity measurement, and extraction. These capabilities in turn helps customers strengthen protection of their identity and data. Okay, so the 2.0 version of the specification includes, okay, support for new logarithms, okay, which can improve driver signing and key generation performance. Okay, so starting with Windows 10, Microsoft hardware certification requires all new Windows PCs includes TPM's 2.0 built-in and enables by default. Okay, with Windows 11, both new and upgraded devices must have TPM's 2.0. Okay, so this is how actually the trusted platform module helps in boosting the security of a device. Okay, it usually protects the sign-in authentication, you can even say that, in the form of BitLocker, my Windows Defender system, okay, etc, etc. Okay, so Microsoft Pluton. So what actually Microsoft Pluton is all about? Pluton, Pluton. Okay, so the Microsoft Pluton security process is designed by Microsoft in partnership with Silicon Partner. Okay, so Pluton engages or enhances the protection in Windows 11 devices, okay, which usually includes secure core pieces with a hardware root of trust, okay, that provides additional protection for cryptography, key, and other secrets. Okay, Pluton is designed to reduce the attack surface. It is integrated. Okay, so then after the security chips directly into the processor, it can used with a discrete TPM 2.0 as a standalone security processor. Okay, when root of trust is located, okay, on a separate discrete chip on the motherboard, the communication path, okay, basically the communication path between the root of trust and the CPUs can be vulnerable or physical attack. Okay, embedding Pluton into PC CPU makes it harder to target the communication path for exploitation. Okay, so then after Pluton support TPM 2.0 industry stands, allowing customers to immediately benefit from the enhanced security in Windows features. Okay, that usually relies on TPMs including BitLocker, Windows Hello, Defender, in addition to providing root of trust. Okay, Pluton also support other security functionality beyond what it is possible with TPM 2.0 specialization, and it's extensible, allowing for the addition Pluton framework so features to be delivered over time via Windows update. For an example, we can give an example of multiple OEMs. Okay, so Plutons to securely integrate with other hardware secure components and system to provide greater visibility to the systems. Okay, so this is how actually the security of Microsoft Pluton is all about. Okay, you can also read, because if I start reading the things, you will not get an understanding unless and until you also read at the same moment, at the same time, so that parallelly we can get an understanding regarding what actually the Pluton is all about and how actually it's securing the Microsoft hardware technology, hardware system integrity with the different encryption decryption keys. Okay, so protection which usually been given. Okay, it usually becomes hard to attackers to identify what set of coding or what set of installation is been done inside even in the Windows 11. Okay, to mitigate or to assist the attack. Okay, so silicon assistant security. So what actually silicon assistant securities are about? So in addition to the modern hardware root of trust, there are numerous other capabilities in latest chips that harden the operating system against the threats, such as by protecting and by boot process security guard that integrates of memory, isolating security sensitive component. Okay, we can say compound logic and more. Okay, so secured cell is best example. Secured cell kernel, okay, not cell kernel, that is usually based on visualization based security, VBM. So then after we'll be having these are set of secured base or VTLs. Okay, and its features. Then after hypervision protected code integrity. Okay, this is also example of that. So then after we'll be having hardware enforced stack protection. Okay, what actually it is and how actually it usually enforces or controls the control flow of enforcement technology, CET, and we'll be discussing all the things. So see, unless and until we will be reading all the things, but I hope we have discuss more about this hardware security. Okay, so let me end the video itself, because it should not be long lasting unless and until, because because the things will fly in sky for you all. So I will end the video here itself. I hope you have understood till the visualization based security, and if possible I'll be dividing it in different or numerous parts, such that you will be getting an understanding regarding what actually this hardware security is all about. So we'll be discussing about hardware security too in the upcoming videos, and we'll be having a clear understanding regarding the secure cell and the process usually been implemented by Windows 11 team to provide its foundational level security, that is all about hardware security. Okay, so again I am even saying you all that if you are new to this channel, please subscribe the channel, like the channel, share the channel as soon as possible. Okay, and get the latest update on the video itself. Okay, so if you have any kind of any set of problem, please make a comment section. Comment section is usually been allowed, and you are free to ask me any doubt on that. Okay, thank you.